Hello and welcome to our last presentation before lunch. Everybody during conferences makes this joke, which I am not going to make. Just hope I will all enjoy the presentation from the team from OLX. Joanna, Anna, and Daria are part of the AI and ML team at OLX, and will explain how to leverage generative AI to improve OLX user experience. As I understand, I'm an OLX user, so I'm really looking forward to that, and I'm sure I will ask some questions at the end. So yeah, the floor is yours.
So hello everyone, my name is Joanna Margol and I am data scientist at OLX Group, and I'm here today with Anya and Daria, and we are excited to present you the topic of AI-driven ad posting and how it transforms the way sellers create their listings at OLX. So let's see what's to expect during this session. First, we will introduce you to the problems related to ad posting that we focused on in developing the solution. Then we will share the details about the GenAI solution. We will deep dive in what's under the hood and share some results. And in the end, we will highlight the key takeaways that we think you should remember after this session. And of course, there will be time also for Q&A. So let's define the problem first. And for better understanding, I will give you some context about OLX. So OLX is our core horizontal app, and it covers huge variety of categories like fashion, electronics, jobs, services, and so on. And with around 70 million active listings on our app each month, we are an active marketplace for users to sell, buy, and even more. But ad posting is quite complex for our users. As you can see, they need to fill in multiple details to post an ad. They need to add title, put images, put description, fill in parameters, add additional information about shipment, contacts, and so on. And the main problems that were detected related to this flow were that first of all, the description is the most problematic field, and we know it, for example, by analyzing the dropout rates related to ad posting. Second thing is that the seller spends too much time on posting because of the long process that you saw on the previous slide. And the third problem is that buyers actually require more information to be able to effectively find what they are looking for. So, knowing all of this together with ad posting team, we decided to develop the GenAI-based solution that will solve these issues. So AI ad posting helps users with most problematic fields based on the lowest possible input, and in this case, it's title and image. The model extracts the parameters of an ad, fill it for the user, and also generates the ready description. So let's see how this AI posting flow looks like from the user perspective. So the user needs to take the photo of an item, then they need to enter the posting form, then they need to type the title, then the category suggester suggests the category of an item, and the user needs to check it. And if it's correct, they need to upload the image. And then after the image is uploaded, we already call the GenAI solution to extract the parameters and also generate a description. So after it's finished, user need to verify these parameters and check if the description fits their needs, and add additional details about shipment, price, and that's all. They are ready to post an ad. So now Daria will tell you more about what's under the hood of this solution.
Yes, thank you, Asia. So I will tell you, yes, how this whole process works. So as you remember, a user opens the posting form, fills the necessary fields, and then the necessary item details are extracted with multimodal LLM, and the listing description is generated. And then a user accept it or not, and provide additional details like price, contact, and so on. And this whole process takes around 4 seconds. So let's start with the first step and how we extract item details using multimodal LLM. So for this step, we need 3 inputs from user. It's item, the photo of the item, it's the title, and it's the category suggested by category suggester. And along with this input, we also receive configuration from our system with all available parameters and its corresponding values for this specific ad. So, for example, here, if user wants to sell these black sneakers, he or she uploads the photo, types this title, for example, comfortable everyday sneakers. The category suggester suggested that it's the category sneakers. The user accepted, and along with this information, we receive configuration with all available parameters for this sneakers category. And these parameters are color, material, brand, and so on. And along with these parameters, we also receive its values like here. So, for example, for color, we have these values like pink, black, and so on. And using this information, we built prompts to multimodal LLM. In our case, we use Lava open source multimodal model to extract information based on the image and text. And we built 2 separate prompts, one to identify the parameters from the input configuration, for example, color, brand, material, so on. And the second prompt is to recognize the state of the item. So is it new or used? And after we receive the output from Lava, we map it to our available values for specific parameters in the input configuration. And if the output from Lava match the values from the configuration, we complete the field with the output from Lava. Otherwise, we don't complete it. And this process of mapping helps us to prevent issues when model generates unexpected values. And the next step is description generation. And for this one, we use inputs like title, like category, and also extracted details from the previous steps. So extracted details from our Lava model. And in this case, in this example with sneakers, Lava recognized that the color is black, also recognized some advantages of this item and the state. And it didn't recognize the material and brand, so it wouldn't be used as input for description generation, but parameters that were recognized will be used as input for description generation. And for description generation, we built a prompt to GPT 3.5 and receive an output, so description in a local language. So in this example we have in Polish language, so the description would be in Polish, but for this presentation it's translated into English, and it's I'm selling new stylish high top sneakers. The shoes are black, perfect for those who value modern design. And next, Asha will tell you about deployment.
Okay, so when users post an ad, once they fill title and upload the image, the backend from the posting flow sends us the request that is routed through Amazon load balancer to our EKS hosted application, which manages all the processing that Daria mentioned. So we are calling a Lava model that is deployed on SageMaker, and here we are also using autoscaler from Amazon to handle current load effectively and allocate all the resources dynamically. So the application is actually calling Lava 2 times, one separate call for state parameter and one call for the rest of parameters. And when the application collects all the information, the prompt is sent to the description generation part, where we currently use an external LLM endpoint with an old version of ChatGPT 3.5. And we generate the description using parameters from the previous step. And once we have all those collected, we send it back to the posting flow, and basically that's how user gets their description and parameters filled in. So when it comes to the metrics, the median inference time is 3.5 seconds. For 90% of requests, we can go below 5 seconds. 350K is our expected daily requests. And right now we have also 1.7% of timeouts, which is mostly because we have set 10 seconds as a cutoff point, because we don't want to degrade the user experience. And you're probably wondering how we ended up in this situation that we host multimodal LLM internally. So we took into account a few factors. Some of them changed over the time, some of them not. So our initial solution was developed in January 2024. And at that time, the inference time of the best-in-class models was longer and costs were higher. But over the time, commercial endpoints improved, and now they're comparable to what we have when it comes to inference time and costs. But there are still a few factors that haven't changed. So I guess all we can agree that self-hosted models are harder to deploy, but it's not impossible, as you can see. And they might not be as good as commercial ones, but they're more controllable and more stable, what is very important for us. Commercial versions of models are changing all the time, and it's hard to make sure that without adjusting the prompts, we will be able to always have the same quality. And also privacy here is a huge advantage because all data stays in our infrastructure. So that's all about deployment. Now Ania will tell you more about quality assurance.
Thank you, Asia. So to assess overall AI at posting performance, we measure 2 factors. The first one is accuracy of the predicted parameters. The second factor is the quality of the generated descriptions. When it comes to parameters extraction accuracy, we compare predicted values with values filled in by the user in historical data. In the first version of our solution, we've reached 76% accuracy score of predicted parameters for fashion category in Poland. When we measure the quality of the generated descriptions, our ground truths are descriptions generated by GPT-4 model. Comparison and quality score calculation is run automatically using DeepEval framework with GEval score. To reliably compare GPT-4 description with description generated by our solution, DeepEval framework is also provided with context, which consists of add title and parameters values. Thanks to that, the model has clear instructions on what to focus on during quality assessment. First version of AI at posting reached the description quality score of 75%. In addition to a GEval score, a small sample of generated descriptions is also verified manually by native speakers. For descriptions quality assessment, we take into account 4 evaluation criteria. And these criteria were created based on the rules that we used intuitively when we were checking the descriptions by ourselves. First evaluation criteria is coherence. We want to make sure that generated description is about the product to sell and nothing else. Second evaluation criteria is completeness and accuracy. All the information from the title and parameters extracted from the image should be included in the final description. We don't want to miss any important information for the potential buyer. By the third evaluation criteria, we instruct the model to check whether the description is grammatically correct. In addition to that, we also want to make sure that the description has a human feeling. LLMs can be very creative, but we just want the model to put all the important aspects of the item into the nice words. And endings like excellent choice for little princess in case of a dress for a little girl are a nice touch, but it cannot be exaggerated. And that is what is checked with the last evaluation criteria. To monitor our production implementation, we introduced periodic evaluation. Each month, parameters extraction accuracy and descriptions quality score is recalculated on the small subset of the new data. And next, these values are compared with threshold values that were calculated previously on the test dataset. If any metric deteriorates too much from these threshold values, we receive alerts. And thanks to that, we can detect and solve issues very quickly. Next, Daria will tell you about model fine-tuning.
Yes, thank you. So now we have GPT 3.5 for description generation, but we wanted more, and we wanted to achieve the quality of the best-in-class commercial models while maintaining the current cost and inference time. And luckily, the fine-tuning solution exists. So the fine-tuned model, in our case, had to be trained to generate descriptions in local languages like Polish, Ukrainian, Romanian, and so on. So for fine-tuning, we used quite small data set. The training data contained only 7K records. And our inputs looked like parameters from historical ads, along with extra details generated by Lava. So here on the slide, you can see how it looked like for one ad. And as output, so as our ground truth, we use descriptions generated by best-in-class multimodal LLM. And just to be sure that we can use it as ground truth, we selected some sample and evaluated it manually. And it was good enough to use it as ground truth. So we used it as output for a fine-tuning process. And here you can see how the output looked like. And our test and evaluation data sets were also not very big. It was around 2K records for each of them. But even with this quite small data set, we received quite good results. As you can see here, the quality score of current solution is much lower than quality score of fine-tuned model. And as base models for fine-tuning for Polish language, we used Kura and Bielik models because they are adapted to Polish language. And for other local languages, we used Mistral. And the next big step is to deploy this fine-tuned model into production. And for this one, we selected machines with AWS inferential accelerators. It's custom designed chips developed by AWS team for deep learning solution. And why we chose it? Because as you can see here, yes, the inference time is higher than the inference time of our current solution, but it's lower than the inference time of a fine-tuned model deployed on the instance with a GPU. And this time and this inference time on inferential machine is acceptable for us. And the quality score is much higher than the quality score of our current solution. So now we are working on deploying it using AWS inferential instances. And next, Anya will tell you about the results and impacts.
Thank you. So A/B tests run for Poland in the fashion category confirmed that ad posting is a great feature for OLX users. Results showed that automated ad posting reduced user effort to fill in parameters section by 58%, and at the same time, 31% more parameters are filled in. And because a lot is done automatically for the users, there is less room for errors, which were reduced by 12%. In addition to that, it turned out that almost half of the generated descriptions is accepted by the users without major changes. But there are still lots of work to be done in ad posting. The first step is to scale the solution to all goods categories and markets in Europe. And also, there are still areas to explore to boost AI ad posting performance. One of them is to test the latest available open source LLMs, which could improve parameters extraction and enhance descriptions quality. In addition to that, there are still other ad posting steps that can be automated, for example, price suggestions. To summarize all that we've talked about, OLX ad posting solution is one of the first user-facing at-scale deployments, which helps millions of users post ads very efficiently and, as a result, to spend less time on selling products. Users don't have to worry about the correct format of the ad. Our solution fills in parameters section automatically, generates descriptions, and takes care of all the trouble for them. Our big success were also fine-tuning experiments. Even though we trained foundation large language models for Polish and Ukrainian on a small data set of 10,000 samples, it turned out to be enough to fine-tune 7 billion parameters models, not only Kura or Bielik, but also Mistral. Fine-tuned models achieved quality metrics higher by around 20 percentage points compared to our base solution with GPT 3.5 model. And as the area of large language models is rapidly developing, we believe that with the latest solutions in the field, we'll be able to bring AI ad posting to the next level. Thank you very much. I hope that you enjoyed our presentation, and if there are any questions, we would be happy to answer them.
Great. Thank you very much. I'm really happy that we have 10 minutes for Q&A. There are quite a few, but I will start with something that came to my head as a user of OLX when reading through your metrics. What about conversion rate? I mean, the thing that I care about is whether I sell or not, or how quickly I sell. Do those AI-generated descriptions convert better than standard ones? Did you measure it?
So
does it make sense, the question?
Yeah, it does make sense. So yeah, we also were measuring the transactions, something like close to transactions. So how many transactions were, if the rate of transactions was higher with this solution and without. And when it comes to that, I guess that we don't have, it wasn't significant enough to share it with you. There is some impact, but not so high, let's say.
So it's mainly, I mean, right now you're basically improving the experience rather than the kind of the final.
Yes. Now we know that that was our initial goal, to improve the experience, to make it better for the user. And now we are focusing also on transactions, on having more new listings on our platform, and our next steps are on it, that we need to also improve it in that way, not only about the user experience.
Yeah, there were some questions around the difference between using prompts and outputs in English versus Polish or Ukrainian, and it seems that you are using both depending on where you are in the pipeline. Is that correct? Like, can you explain this?
Yes. So we tried prompts in local languages and in English, and for description generation, we have prompts in local languages for each market because it showed better results than one prompt in English. But for parameters extraction, this prompt is in English because for description generation we use GPT, and it worked better with local languages, but for extraction details we use this Lava model, and it worked better with English prompt, and it's also a dynamic prompt, so it depends on the category, so that's why we used it in English, and it showed us better results than local prompts.
Okay, interesting. And do I understand correctly, you are still using GPT 3.5 at the moment? And why not for O Mini, which is, I guess, basically a replacement for 3.5?
So we are going to use 4 Mini for now. On the production, we have 3.5, and we are currently testing how it would look like with the 4 Mini. We need to evaluate all the descriptions and then switch to 4.0, and that's our plan. To be honest, it's cheaper and so on. So.
Yeah, because testing is time-consuming, because these descriptions should be evaluated, and not only automatically, but also by native speakers. So that's why it's not so fast.
And another question that I see on the chat: what is the I'm not sure if I understand it correctly, so maybe I'll just read it. What's the source of training data? The data from production, or it was generated as valid possible test data? Well, actually, I do understand the question. Whether you're actually using your production data or synthetic data for fine-tuning or anything else like that.
If it comes for fine-tuning as input, we used our production historical ads, so our real data. But as outputs, so as description generated, descriptions, we used this synthetically data from GPT-4 Vision. And before we used it as output, we of course evaluated it manually if it's okay. But as input, it was real data. As output, it was descriptions by GPT-4 Vision.
And you mentioned this, as I understand, overall quality score, 0.75 or 0.9. Could you give us some details how this is calculated? I either missed it or maybe you didn't include it in the presentation.
So there were two scores. The first score was parameters extraction accuracy. And it was calculated comparing the user values that were filled in on the platform with the values that were predicted by our solution. So it's just the classical accuracy score. And the second score for descriptions quality, It is the G-eval score, which is calculated automatically by a DevEval framework. And here we are comparing the description generated by our solution, so with GPT 3.5, with the description generated by the GPT-4 model. And to compare these descriptions, we are using these 4 evaluation criteria that I presented. And DevEval framework is converting these evaluation criteria using the technique.
Okay. I understand now. Yeah, thank you. Yeah. No, I mean, you can continue, but now it clicked for me. Yes.
Okay.
There was also a comment about the size of your fine-tuning data, that it seems quite low, but you also mentioned this, that it was actually, I think Anna explained this, that this was actually enough to give you solid results. Is that correct?
Yes, exactly. Yes. So we tried with a small data set because, as I mentioned, yes, we needed to evaluate it manually. So that's why we started with some small data set, and we saw that the results are quite good. So we stayed with it.
Okay. The last question I see here: do you calculate the cost of such solution of increasing user experience? Again, I'm not sure if I understand it correctly, but if you do, then feel free to answer.
So I know the cost of the request to create, let's say, or the whole request for the user. So this is 1.75 cents, if I'm correct. Yeah, so that's the cost, but I guess we're not scaling it because I think that question is about how it's scaled to the user.
But is it actually deployed for all the users, or like is it deployed for some small subset? How do you run it at the moment?
So it's deployed for the whole category in Poland, for the whole fashion category in Poland.
Fashion. Okay, yeah.
Fashion in Poland, yes.
Okay. Sorry for all these questions. I'm grinding you at the end, but again, the topic is so interesting and we had some time for it. I don't see any more questions on the chat. I think we can stop here. So again, Joanna, Daria, Anna, thank you for this very interesting presentation, and everybody else. Hope you enjoyed. There is a lunch break coming. Now there is also some talk during the lunch break. You can connect and check it out. This is actually my last session that I'm chairing, so thank you all, and I hope you will enjoy the rest of the day. Thank you.
Thank you.
Thank you.